All right, guys, this is our second video on graphing transformations of functions. We're going to continue talking about rigid transformations in this video. And here we're going to start looking at reflections of functions. We say that making the x negative reflects a function across the y-axis. Right? So making the x negative inside the function is going to give us a reflection across the y-axis. And that reflection we would define as, of course, a horizontal reflection. Now, one thing we can say is that a reflection across the y-axis is always going to be a horizontal reflection, right? Flipping the function over the y-axis. But we may not always see that horizontal reflection happen over the y-axis itself. But making the x negative will always be a horizontal reflection. So right here, if we're looking at an example, we've got f of x equals the square root of x, right? It's 1/2 of a sideways parabola. And we want to take a look at what's actually happening when we make x negative inside that square root. So when we make x negative, right, basically what we're saying is that all of the positive x values we plug in are going to now be negative x values. And all of the negative x values are going to be negative negatives or positive x values. So now the square root sees the positive x-axis as the negative x-axis and the negative x-axis as the positive x-axis. And that gives us the graph flipped across the y-axis. Right? So basically we're seeing a flip of the x-axis, right, over the y-axis, and it's giving us that horizontal flip right there. If we're looking at vertical reflections, right, we say that vertical reflections, with vertical reflections, we say making the entire equation negative reflects the function across the x-axis. And this is always going to be true. It may be that a horizontal reflection doesn't always happen over the y-axis, but a vertical reflection is always going to happen over the x-axis. And of course we can see here again, a vertical reflection, a flip over the x-axis is going to reflect us vertically. Now we say that this happens, of course, when we make the entire function negative. And in general, what we can think from our example right here is that just like before when we talked about translations, that square root is really defining the y values in the ordered pairs of our function, right? And what we're doing when we make that square root negative is we're making all of those y values negative. So we go from ordered pairs that look like xy to ordered pairs that look like x negative y, right? So all of those previously positive y values that we're seeing in these ordered pairs are now being made negative. And we see the reflection of that sideways parabola across the x-axis there. Okay, so what I want you guys to do is to try a couple of these. We want to look at reflecting this function first across the x-axis, right? And across the x-axis is going to be a vertical reflection. You may feel like it should be horizontal because we're talking about the x-axis, but again, we're talking about a flip over the x-axis. So that's going to be a vertical reflection. And we want to reflect this same function across the y-axis, which of course is a horizontal reflection. So why don't you guys pause the video now and give this one a shot. Okay, so looking at this first example right here, we're vertically reflecting our function, right? Which means that we want to take all of the positive y values of the ordered pairs of our function and make them negative, flip them over the x-axis, right, making them negative, right? And we want to take all of the negative x value, or negative y values rather, and make them positive. So all of those negative y values, we're going to make them positive. We're basically seeing a flip of the y values in our ordered pairs. And what defines the y values in our ordered pairs? Our equation right here. So right here, what we want to think is this guy, the equation, is defining the y values. So an equation that will make those y values switch signs is going to be an equation that is made negative. So right here we would say negative x squared minus 5x plus 2. If we make that equation negative, it's going to flip all the y values, giving us negative y values in our ordered pairs. And right here we can even simplify that a little bit. Right here we could say that would be y equals negative x squared, and then right here plus 5x, and right here minus 2, and that would give us a graph that looks something like this. I'm going to do this. So right here, this is approximately this graph right here. Right? And what we can say here, if we look at the equation, is we've got a negative x squared, which we know is going to make our parabola open down. And we've got a negative 2, which is, of course, the reflection of that y-intercept across the x-axis with our approximate graph right here. Okay, so let's take a look at the horizontal reflection now. With this horizontal reflection, we want to think that we are going to change all of the x values in the ordered pairs from positive to negative, right? And so right here, that means that we will have to go inside and make those x values negative. So we're going to be looking at negative x squared, and then minus 5 times negative x, and then plus 2. We simplify this guy, and we get y equals x squared. Negative x squared is x squared, and then right here positive 5x, and then right here plus 2. And right here this would be a reflection across the y-axis, which is going to give us something that looks like this. You can do a bunch of things to test this. You can type it into the calculator. We could say that the x value of our vertex, right, the h value, we define as negative b over 2a, right? And so for our function right here, negative b over 2a is going to mean a negative 5 over 2, which would be an h value of 2.5. And right here, that's going to mean a negative 5 over 2, which is negative 2.5. So right here, we can see the difference in sign in the vertex value of our parabola, which would indicate that reflection. Okay, so we've got two more problems, a little more challenging here maybe. We want to go ahead and see if we can get a reflection across the x-axis, vertical, and a reflection across the y-axis, horizontal. For our function right here, f of x equals the square root of x. That is a graph that's going to look something like this. We've got our domain from negative 3 to positive infinity, so we're looking at 1/2 of a sideways parabola starting at negative 3 and extending out to positive infinity. Why don't you guys pause the video and give this one a try. Okay, so right here again, a reflection across the x-axis is going to come from making the equation negative. So we have y equals negative square root of x plus 3. And what you can see here is all of the y values that would come from the square root of x plus 3 are now being made negative. So we get the graph of the bottom half of that sideways parabola reflected from the top half of the sideways parabola. If we're looking at reflecting horizontally, right, we are going to go directly into our equation and make that x negative. So right here, we would say that we want to go in and say we've got a negative x and then plus 3. Again, we're flipping where the function evaluates negative and positive x values. And in general, one way you can sort of see this, we might simplify it a little bit and say we've got y equals the square root of negative x plus 3, just sort of take down those parentheses so we can see a little better. One way we can sort of see this is a horizontal flip should in fact flip the domain, right? We're seeing a domain from our first function from negative 3 to positive infinity, right? And we should see that domain flipped for this reflection. Now right here, if I evaluate the restriction on my domain, no negatives under the radical, I get negative x plus 3 cannot be less than 0. And if I add x to both sides, I'm saying x cannot be greater than a positive 3, which means that my domain is ending at 3 and starting at negative infinity. And that would be that would sort of indicate that reflection right there. So right here we've got that function going out to negative infinity from positive 3, where previously we started negative 3 and went out to positive infinity like that. So a bunch of different ways you can sort of rationalize seeing this reflection, but these are the two equations that are going to give us a vertical reflection and a horizontal reflection respectively. Okay, so right here we've got a tricky problem for you guys. I want you guys to take a look at this one. We are given the function f of x equals 1 over x, and I want you guys to come up with an equation that has a vertical asymptote at negative 3, increases on its domain, and has a horizontal asymptote of 5. If we look at this original function right here, we can say we've got a vertical asymptote of x equals 0, a horizontal asymptote of y equals 0, and in general we can say we are decreasing on this function's entire domain. So decreasing. On domain. So what I want you guys to do is to pause the video and try to come up with an equation that will have these characteristics. And that equation should be a transformation from our original equation. Okay, so right here, the first thing I want to look at is getting a vertical asymptote at negative 3. Well, that would be a horizontal shift of my vertical asymptote at 0, 3 in the negative direction. And that means that the first thing that I'm going to want to do is to take my original function and add 3 directly to the x in the denominator, right? Now, basically what that's going to do is it's going to take this graph, vertical asymptote, and shift it. I'm going to have to move it over myself. Right here, move it over 3. So now we've got x equals negative 3, rather, as a vertical asymptote. Now we want to see it increase on its domain. Well, if it's decreasing on its domain, a vertical flip would make it increase on its domain. So right here, the next thing we can do is to go ahead and make our entire equation negative. And I'm just going to go ahead and make the entire equation negative. I can do that with a negative right there. And now we've got this. I have to draw this in a color that we can see, so I'm going to do it in red. We've got this function that has a vertical asymptote at negative 3 and a horizontal asymptote at 0. It's actually going to be flipped now. See if I can sort of flip this guy. Flip up and down, and I'm going to flip this guy up and down. And now these two pieces flipped across the x-axis are now increasing on, now make the function increasing on its entire domain. Lastly, what we want to do is move that horizontal asymptote from 0 up to 5, right? And basically what that means is taking all of the y values that defined the horizontal asymptote at 0 and moving them all up 5. So right here what we can do finally is add 5, and that is going to vertically shift our function up 5. So now we're seeing that horizontal asymptote at positive 5. I'm going to erase some of this stuff that we've got right here so that we can sort of see this a little bit better. We've got that horizontal, I'm going to do that green, horizontal asymptote at positive 5, and there is the transformations that do it. So right here we first moved a vertical asymptote horizontally to negative 3 by adding 3, right? We next next flipped our graph, right? Changing it from decreasing on its domain to increasing on its domain. We flipped it vertically by making the equation negative. And finally, what we did was we added 5 to the equation itself to move all of the y values of the equation up 5. And this right here would be the equation that would satisfy these criteria and be a transformation from our original function right there. Okay, so now what we want to talk about is the effect of absolute values outside and inside the function. So right here we've got our function, the parabola x squared minus 5x plus 2, same one we looked at before. What's going to happen when I make the entire function, when I put the entire function in the absolute values, essentially making it all positive? Well, right here, what we're saying then is that we're taking all of those negative function values, right, and the absolute value is going to make them all positive, right? Because that's what the absolute value does. It's the distance from the origin, and distance is always positive. So what we're seeing right here is a graph where all of the function values, or the y values of the function, have been made positive, and it would look something like this. You guys saw something like this on your review packet for your first quiz. And the reason for it is that all of the y values that are coming from this guy, right, in the ordered pairs, right, x, y, of our parabola, right, all those y values now must be positive, right? So right here we take those y values and we put them in the absolute value when we make that equation. When we put that equation in the absolute value, we get a graph that looks something like this. Okay, so right here, what's going to happen if I make the x itself, if I put the x itself in the absolute value? Well, of course, that's going to mean the x values are all going to be positive, right? Since when we take the absolute value of negative x values, they become positive. The function is now addressing both axes, or both sides of the x-axis as the positive x-axis, right? So basically what we're seeing is a repeat of what it does on the positive x-axis on the negative x-axis. So that piece right there is going to now happen twice because, again, the function is only evaluating positive x values. Where it gets negative x values, they're still positive, and it looks something like this. That is a rough drawing. Pretty rough. Maybe I can just bring this guy over. Looking something like that. Again, right here, the negative x values are plugged into the function values, and then they're evaluated. So essentially, it's evaluating the x values as though they were on the positive x-axis twice, on the negative x-axis, and then again on the positive x-axis there. Okay, so right here, we are going to jump to the next video now. I want you guys to stop this one, and we'll see you on the next video.